Alright, so in this video, we actually, in the previous video, we talked about the terminal velocity concept. In this video, we'll be actually explaining the graph or elaborating a little bit more. So this is the terminal velocity graph in which I explained the behavior, why does this behavior, why do we have this sketch of terminal velocity graph. So in this video, I'll be just, elaborating a little bit more. So at first, we see the line to be constantly going in a linear fashion, right? Like this. So it has a constant slope up till this point. So the slope of this graph is constant. Whenever we have the constant slope, like it is not changing, it is just going, although it is positive but constant as well, because it is not, getting a zigzag pattern or, exponentially getting increased like that. It is just going upward in a straight line. So it has a positive gradient. Whenever we have a positive gradient, we have an acceleration, a positive acceleration, right? So the thing is said to be accelerating because it has a weight and it is providing the downward force. And the air resistance right now, right in the start, because of very little velocity, the air resistance is pretty small, right? So it has overall net force that is acting downwards, which is providing the acceleration. We can validate from the Newton's second law. So it is going down, it is accelerating. But as soon as it starts to gain velocity, the air resistance starts to play its role even more, and the air resistance starts to increase more and more, and at one point it starts to balance the weight of that, right? So when the air resistance starts to balance the weight of the ball or anything that is falling down, the net force is going to be zero, because net force is always the sum of the forces, and the resistive force is acting upwards and the weight is acting downwards, so they will have opposite signs and they will cancel the effect of each other, and the net force is going to be equal to zero. And when net force is zero, the acceleration is going to be zero from Newton's second law, and then the velocity, the change in velocity of that thing is also going to be zero, and gradually this line will actually cease to actually, go further up, and it will go flat. The gradient will now be zero. So if you just calculate the gradient of this line from this point onward, it is going to be zero because it is flat, right? So this is the reason that we actually observe this trend in the motion of anything falling down, that it starts to accelerate. At one point it reaches terminal velocity, and then the line actually gets flat. So this is the case of anything falling down in the presence of air resistance, given that it was thrown up from a height that it allowed the air resistance to act on it.